In named reactions of aldehydes and ketones, there are three types of reactions: condensation type of reactions, reduction reactions, and oxidation reactions. In condensation reactions, there are 6 reactions given. In reduction, there are 3, and in oxidation, there are 2. Now, in today's lecture, we are going to discuss about condensation reactions, which are given for your syllabus. First reaction that we are going to discuss is Knoevenagel condensation reaction. The second one is Perkin reaction, and the third one is Reformatsky reaction. These are the 3 condensation reactions that we are going to discuss in this session. आपल्या नेम्ड रिॲक्शन्स ऑफ aldehydes अँड कीटोन्समध्ये एकूण 3 प्रकारच्या रिॲक्शन्स दिलेले आहेत: कंडेन्सेशन रिॲक्शन्स, रिडक्शन रिॲक्शन्स आणि ऑक्सिडेशन रिॲक्शन्स. ह्या टॉपिकमध्ये एकूण 11 रिॲक्शन्स आहेत आणि हा टॉपिक जवळपास 15 मार्काला परीक्षेमध्ये विचारतात. त्यामुळं हा अतिशय महत्त्वाचा असा टॉपिक आहे. फर्स्ट युनिट आहे आपल्या सिलेबसमधला. आजच्या आपल्या हे लेक्चरमध्ये आपण 3 रिॲक्शन्स पाहणार आहोत: नॉवेंजल कंडेन्सेशन रिॲक्शन, Perkin reaction and Reformatsky reaction. Before that, we will see what is meant. Before discussion about these 3 condensation reactions, first of all we will see what is meant by condensation reaction. Condensation reaction म्हणजे काय? A reaction in which 2 or more molecules combine to form a large molecule with the simultaneous loss of a small molecule such as water or methanol. That reaction is called as condensation reaction. Condensation reaction म्हणजे 2 मॉलिक्यूलचं कॉम्बिनेशन आहे, ॲडिशन आहे थोडक्यामध्ये. कॉम्बिनेशन ऑफ 2 मॉलिक्यूल्स टू फॉर्म ए लार्ज मॉलिक्यूल. त्याच्यापासून एक मोठा मॉलिक्यूल आपल्याला मिळतो विथ द सायमल्टेनियस लॉस ऑफ स्मॉल मॉलिक्यूल सच ॲज वॉटर ऑर मिथेनॉल. ज्या रिॲक्शनमध्ये 2 कंपाऊंड्स एकमेकासोबत रिॲक्ट होतात, कंबाईन होतात, त्यांच्यापासून एक मोठा मॉलिक्यूल मिळतो, परंतु त्याच वेळेला त्या रिॲक्शनमध्ये वॉटर किंवा मिथेनॉलसारखे छोटे मॉलिक्यूल्स बाहेर पडतात. त्या रिॲक्शनला म्हणायचं कंडेन्सेशन टाईप ऑफ रिॲक्शन्स. For our syllabus, there are 6 reactions given, condensation reactions. The first one is aldol condensation, benzoin condensation, Knoevenagel reaction that we are going to discuss today, Mannich reaction, Perkin reaction, and Reformatsky reaction. Now we will see what is Knoevenagel condensation reaction. Knoevenagel condensation reaction is named after Heinrich Emil Albert Knoevenagel, who was a German chemist and who had given this Knoevenagel condensation reaction. This Knoevenagel condensation reaction, ही Knoevenagel condensation reaction ही Heinrich Emil Albert Knoevenagel ह्या सायंटिस्टच्या नावावरून ह्या रिॲक्शनला ते नाव दिलेलं आहे, कारण ह्या सायंटिस्टने ह्या रिॲक्शनचा शोध लावलेला आहे. जर्मन केमिस्ट हेनरिच नॉवेंजल. This is that scientist, Knoevenagel. Now, what is Knoevenagel condensation reaction? Condensation of aldehydes and ketones with compounds having active methylene group in the presence of basic catalyst to form alpha beta unsaturated compound is called as Knoevenagel condensation reaction. ज्या कंडेन्सेशन रिॲक्शनमध्ये अल्डिहाइड आणि कीटोन्स हे ॲक्टिव्ह मिथिलीन ग्रुप असलेल्या कंपाऊंडबरोबर रिॲक्ट होतात आणि त्यांच्यापासून अल्फा बीटा अनसॅच्युरेटेड कंपाऊंड्स तयार होतात, त्या रिॲक्शनला म्हणायचं नॉवेंजल कंडेन्सेशन रिॲक्शन. नॉवेंजल कंडेन्सेशन रिॲक्शन म्हणजे काय? ज्या कंडेन्सेशन रिॲक्शनमध्ये अल्डिहाइड आणि कीटोन ॲक्टिव्ह मिथिलीन कंपाऊंड असलेल्या ॲक्टिव्ह मिथिलीन ग्रुप असलेल्या कंपाऊंडबरोबर रिॲक्ट होतात आणि त्याच्यापासून अल्फा बीटा अनसॅच्युरेटेड कंपाऊंड तयार होतात, त्या रिॲक्शनला म्हणायचं नॉवेंजल कंडेन्सेशन रिॲक्शन. For example, we will see one example here. Benzaldehyde is reacting with diethyl malonate. डायइथिल मॅलोनेट बरोबर बेन्झाल्डिहाइड आपण रिॲक्ट केलेला आहे. म्हणजे ह्या रिॲक्शनमध्ये आपण एक अल्डेहाइड वापरलेला आहे आणि ॲक्टिव्ह मिथिलीन कंपाऊंड घेतलेला आहे, दॅट इज डायइथिल मॅलोनेट. बेन्झाल्डिहाइड अंडरगोज कंडेन्सेशन विथ डायइथिल मॅलोनेट. Ethyl malonate is compound having active methylene group. In the presence of an organic base, that is piperidine, to form alpha beta unsaturated ester, which undergoes hydrolysis and heating to give cinnamic acid. Now see here what happened. What is the reaction here? This is active methylene group, and therefore this diethyl malonate is called as active methylene group containing compound. Methylene CH2 group is called as a methylene, and that methylene group is active because of these two electron withdrawing groups here, and therefore this total compound, that is diethyl malonate, is an example of active methylene group containing compound. It is reacting with benzaldehyde, and there is use of base here, piperidine, which is an organic base. It is giving such type of alpha beta unsaturated ester. This alpha beta unsaturated ester, which is obtained, undergoes hydrolysis and decarboxylation. Hydrolysis and heating. Heating gives carbon dioxide, that is decarboxylation. And therefore this is an example of Navinger reaction, that is benzaldehyde reacting with diethyl malonate in the presence of an organic base piperidine to form alpha beta unsaturated ester, which undergoes hydrolysis and heating to give cinnamic acid. This is example of Navinger condensation reaction. Now before going towards mechanism समजून घेण्याच्या आधी अल्फा बीटा म्हणजे काय हे समजून घ्या. या ठिकाणी आपण दिलंय की अल्फा बीटा ईस्टर, दिस इज अल्फा बीटा unsaturated ester. What is meaning of alpha beta unsaturation? That we will see here. See here, this is carbon. This is our functional group. Carbon which is directly attached to functional group is called as alpha carbon, and which is attached to alpha, it is called as beta carbon. There is unsaturation between alpha and beta, therefore it is called as alpha beta unsaturated acid. Similarly, this is called as alpha beta unsaturated ester because there is alpha carbon and there is beta carbon which have unsaturation here. In short, we can say that carbon which is directly attached to functional group is alpha carbon, which is attached to alpha, it is called as beta, then gamma, then delta. This is the basic idea regarding alpha beta. Now we'll see mechanism of Navinger condensation reaction. There are so many steps involved in this mechanism. We will see one by one. Proton abstraction by base from diethyl malonate to form a carbanion. See here, this is the reaction in which base, that is piperidine, which we had used, it is reacting with diethyl malonate, active methylene group containing compound, and there is formation of carbanion here. In this mechanism, this is base, it is abstracting this proton is abstracted, and there is formation of Hb here, and there is formation of carbanion here. That means this is carbanion, which is called as carbanion. This is the first step, that is carbanion formation from diethyl malonate with the help of base is the first step in Nobel condensation reaction. But in the second step, carbanion prepared in the first step reacts with benzaldehyde molecule, another benzaldehyde molecule. In this reaction, this benzaldehyde molecule we are using, carbanion obtained from diethyl malonate reacts with benzaldehyde, carbonyl carbon, and there is formation of negatively charged oxygen atom. Now in the third step, this oxygen will get protonated. Here. This is the HB which is obtained in the first step. Now elimination of water molecule in the fourth step. OH from one carbon and H from another carbon, there is loss of water molecule and there is formation of such type of compound. These are three steps. Now in the fifth step, there is hydrolysis to get one, that is acid, and which after decarboxylation undergoes heating for decarboxylation and it gives cinnamic acid. This is the complete mechanism of Nobel condensation reaction. See here, there are 6 steps given here, but this mechanism can be summarized in one format also. This is the first one, that is formation of carbanion, and that carbanion reacts on benzaldehyde. There is formation of negatively charged oxygen. See here, this is base, this is diethyl malonate. There is formation of carbanion here. This carbanion is reacting with benzaldehyde molecule to form negatively charged oxygen, which gets protonated here. There is formation of OH here, and OH and this hydrogen, there is loss of water molecule and therefore there is formation of double bond, and this ester obtained undergoes hydrolysis and decarboxylation to give a cinnamic acid. You can write mechanism in steps also, or this page you can use for mechanism of Nobel condensation reaction. म्हणजे नॉवेंजल कंडेन्सेशन रिॲक्शनच्या आपण ज्या 6 स्टेप्स दाखवल्यात, तुम्ही परीक्षेमध्ये 6 स्टेप एकाखाली एक लिहून सुद्धा मेकॅनिझम दाखवू शकता किंवा एकत्रितरित्या ही मेकॅनिझम सुद्धा दाखवू शकता. दोन्हीपैकी कुठली एक मेकॅनिझम तुम्ही परीक्षेमध्ये वापरू शकता. Now second one is Reformatsky reaction. Reformatsky reaction was discovered in 1887 by Russian scientist Sergei Nikolaevich Reformatsky. Therefore the name of reaction is Reformatsky reaction. This is that scientist, that is Reformatsky, Sergei Reformatsky. What is Reformatsky reaction then? The reaction of aldehydes and ketones with an alpha haloester, usually alpha bromo ester, in the presence of zinc metal to produce beta hydroxy ester is called Reformatsky reaction. ज्या रिॲक्शनमध्ये अल्डेहाइड अँड कीटोन्स हे अल्फा हॅलो इस्टर बरोबर रिॲक्ट होतात आणि त्यांच्यापासून बीटा हायड्रॉक्सी इस्टर मिळते, त्या रिॲक्शनला म्हणायचं रिफॉर्मॅट्स्की रिॲक्शन. द रिॲक्शन ऑफ अल्डेहाइड्स अँड कीटोन्स अगेन with an alpha halo ester. Alpha halo ester, generally bromo ester we are using here, in the presence of zinc metal to produce beta hydroxy ester is called as Reformatsky reaction. We will see one example. This is an example in which benzaldehyde reacting with alpha bromo ester in the presence of zinc to give beta hydroxy ester. This is an example of Reformatsky reaction, in which benzaldehyde is reacting with alpha bromoester to give beta hydroxy ester. This reaction is called as Reformatsky reaction. The reaction in which, what is the Reformatsky reaction? The reaction of aldehydes and ketones with an alpha haloester, usually alpha bromoester, in the presence of zinc metal to produce beta hydroxy ester is called as Reformatsky reaction. Now this is an example in which benzaldehyde is reacted with alpha bromoester and there is formation of beta hydroxy ester. This is an example of a Reformatsky reaction. Now we'll see its mechanism. Mechanism of this reaction is very simple as compared to previous one. Mechanism involves different steps. In the first step, there is reaction between zinc and alpha bromoester to form organo-zinc compound. This is alpha bromoester reacting with zinc in the presence of benzene to give organo-zinc intermediate. That is, formation of an organo-zinc intermediate is the first step in the Reformatsky reaction mechanism. That intermediate adds to carbonyl carbon of benzaldehyde to form a complex with zinc and bromine. Now in the third step, hydrolysis gives beta hydroxy ester, that is obtained complex undergoes hydrolysis and to give beta hydroxy ester. These are three steps involved in the mechanism of Reformatsky reaction. We can summarize them on the single page. See here, beta alpha bromoester reacting with zinc to give organo-zinc intermediate. That organo-zinc intermediate is reacting with benzaldehyde to give complex, and then that complex undergoes hydrolysis to give required beta hydroxy ester. This is mechanism of Reformatsky reaction. Now we will see Perkin reaction. Perkin is English scientist William Henry Perkin who had given this reaction. Therefore, this reaction is called as Perkin reaction. In the Perkin reaction, aromatic aldehydes react with aliphatic acid anhydrides in the presence of sodium or potassium salt of that acid, from which that acid anhydride is prepared to give alpha beta unsaturated acids, is called as Perkin reaction. The condensation reaction in which aromatic aldehydes react with aliphatic acid anhydrides. ज्या कंडेन्सेशन रिॲक्शनमध्ये ॲरोमॅटिक अल्डिहाइड्स हे ॲलिफॅटिक ॲसिड अनहायड्राइड्स बरोबर रिॲक्ट होतात इन द प्रेझन्स ऑफ सोडियम ऑर पोटॅशियम सॉल्ट ऑफ दॅट ॲसिड. म्हणजे सोडियम आणि पोटॅशियम सॉल्ट त्या ॲसिडचं ज्याच्यापासून ॲसिड अनहायड्राइड्स तयार झालेले आहेत टू गिव्ह अल्फा बीटा अनसॅच्युरेटेड ॲसिड्स इज कॉल्ड ॲज Perkin reaction. Remember that what is necessary condition here? The acid anhydride should have at least 2 hydrogens. This is the necessary condition for Perkin's reaction. Now we'll see one example. Benzaldehyde reacting with acetic anhydride to give cinnamic acid. This is an example. In this reaction, aromatic aldehyde is benzaldehyde. Acid anhydride is acetic anhydride. In the presence of sodium salt of that acid, means acetic anhydride is prepared from acetic acid. Therefore, we are using here sodium acetate at 180 degrees Celsius to form cinnamic acid. This is an example of Perkin reaction. Benzaldehyde reacting with acetic anhydride in presence of sodium acetate at 180 degrees Celsius to form cinnamic acid. That means here aromatic aldehyde, that is benzaldehyde, reacting with acid anhydride, that is acetic anhydride, in the presence of sodium or potassium salt, that is acetic acid, sodium salt of acetic acid, and there is formation of alpha beta unsaturated acid. Alpha beta unsaturated acid, in this example the product obtained is cinnamic acid. This is an example of Perkins reaction. Now we'll see its mechanism. Mechanism of Perkins reactions involve different steps. See here, this is sodium acetate. This is sodium acetate which undergoes ionization to form acetate ion and sodium positively charged. This is acetate ion. Now that acetate ion abstracts a proton from the carbon of the anhydride, producing a carbanion A. See here, this acetate ion is abstracting proton from acid anhydride, and there is formation of, this is acetic anhydride, there is formation of acetic acid, there is formation of carbanion here. See here, in this is acetate ion, it is abstracting this proton and there is formation of acetic acid. Now at the same time, this anhydride turns into carbanion, that is carbanion A. That means carbanion formation is the first step in Perkins mechanism. Now in the next step, second step, addition of A, carbanion A obtained in the first step reacts with carbonyl carbon of benzaldehyde to give B. This is carbanion A reacting with benzaldehyde to give B. Protonation of B gives C. Proton is supplied by acetic acid produced in the first step. See here, this is carbanion A which is obtained in the first step. It is reacting with carbonyl carbon and there is formation of negatively charged oxygen here, and that is protonated. Addition of proton is called as protonation. This protonation of B, protonation, this is B, complete B. Protonation of this B gives OH ion here, and that is formation of C. That is the third step. Steps are shown here. Second step, this is third step. Now there is formation of C now. That C, internal protonation, there is elimination of water molecule in the fourth step. See here, internal proton transfer. That means here there is formation of water molecule, loss of water molecule here, and there is formation of alpha beta unsaturated ester, which undergoes hydrolysis. This D obtained in the fourth step undergoes hydrolysis, addition of H2O, and there is formation of required product, that is cinnamic acid. Now this is the fourth and fifth step involved in Perkins reaction. Now we can summarize the Perkins reaction mechanism as like this. Formation of carbanion A which attacks on carbonyl carbon to give B, which after protonation gives C. That C after elimination of water gives alpha beta unsaturated compound D, and D undergoes hydrolysis in the fifth step to give cinnamic acid. This is mechanism of Perkins reaction. So friends, here these are some questions which may be asked in the examination. Explain Navigel condensation reaction with mechanism. Explain Reformatsky reaction with mechanism, and give mechanism of Perkins reaction. तर ह्या तीन क्वेश्चन्स ची तयारी करा. मेकॅनिझम ऑफ पर्किन रिॲक्शन जरी म्हणलं तरी पर्किन रिॲक्शन म्हणजे काय, ते तुम्हाला लिहावंच लागेल, त्याचं एक्झाम्पल लिहावं लागेल आणि त्याची मेकॅनिझम लिहावं लागेल. These are three condensation reactions which we had discussed in this session or lecture. Thank you very much, and in the next we will discuss remaining two condensation reactions, that is aldol condensation reaction and benzoin condensation reaction.